Hi there! Building a whole circuit on a breadboard and building it on a PCB is not quite the same thing. Besides the obvious thing that you don't need to solder on the breadboard, there are other issues that make things very different when the circuit involves generation and manipulation of high frequencies, especially in the case of the theremin. And in fact, because of the differences in parasitic capacitances and inductances between the breadboard and the PCB, I had to make some slight changes to the design of the audio generator. Fortunately, the changes were not significant, so I was able to still use the same PCB I had previously designed. So let's now take a look at what I did, how the circuit was assembled, and how it was tuned. It was during the tuning part that I realized that something had to be changed. Before diving into the details, please take a moment to subscribe to the channel and click on the bell to receive notifications when I publish new videos. The subscription will also help a lot in making this channel grow and serve you better. Let's begin. Here is the full schematic of the audio generator. In the upper left we have the Pitch Reference Oscillator with its two op-amps NE5534P. The Pitch Variable Oscillator is here on the bottom left. You can recognize the actual oscillator with its resonating tank composed by C15, C16, L1, L3, L4 and L5. The antenna is connected to this H3 pin header. On the right side sits the Heterodyne mixer, picking up the signals from the two oscillators through the capacitors C21 and C22. The output of this mixer is connected to the pin header H2. And finally, the power supply of the whole circuit comes from the pin header H1, which provides both positive and negative voltages with respect to the ground. As I already anticipated, the circuit needed some slight changes to improve the handling of the instrument and to compensate for the parasitic reactances of the PCB. We will get back to these changes later on, once we get to talk about the tuning of the corresponding part of the circuit. For that, I suggest that you go through the whole video, so you won't miss any important detail. Note that the change due to the PCB compensation should work for anyone that builds the circuit following my design and using the same PCB I provide. If you are going to design your own PCB, results could be different and you might have to use different values of the components. I will make available a new bill of materials and a new PCB layout with the final changes in the usual repository on eleneasy.com, so you can build your own audio generator following my exact design. Look for the details in the video description below. I assembled the components one section at a time. I started with the Pitch Reference Oscillator, followed by the Pitch Variable Oscillator and finally the Heterodyne mixer. But when I started, I found something that made me blush. I realized something that I should have seen before. Talking about quality control. When checking that the PCB connected the components according with the schematic, I totally dismissed the fact that the trim-pot traces on the PCB were for surface mount components, while instead I had through-hole trim-pots. So I had to arrange the pins of the trim-pots to make them fit in traces I had on the PCB. This will need to be changed to the final PCB, of course, but don't worry, the final version of the PCB that will go on the eleneasy.com repository will have this correction and all the others that are mentioned later in this video. Going back to the circuit assembly, all the integrated circuits were installed using sockets, and that helps in two ways. First, soldering the socket instead of the IC prevents damaging the IC itself due to excessive heat. And second, this allowed me to insert the ICs on the sockets one section of the circuit at a time, and do some tuning in between, so to make sure that the section I was tuning was isolated from the rest of the circuit. Another thing that I changed is the connection of the potentiometer for the pitch adjustment. During the tuning, I found that using connectors on the PCB caused some noise in the signal. The connectors were interfering with the high frequency of the wave. So I ended up soldering the cable of the potentiometer on the PCB itself. No change to the PCB in this case, but I had to desolder the connector I had put already in there. Tuning of the audio generator was a multi-step process. First, without any op-amp installed on the circuit, I tuned to input R18 to obtain a reading of 0 volts on the collector of transistor Q1. This reading can be done either with an oscilloscope or with a digital voltmeter that has a high impedance. Once that was done, I inserted in the sockets the op-amps of the Pitch Reference Oscillator, U1 and U2. With those in place, I tuned first the inputs R7, R8 and R10 so I could get on test point 1 the best possible sine wave shape with a reasonable amplitude that would not cause any distortion of the signal. Now, the tuning of these three inputs needs to be done in several passes because the tuning of one tree input affects the tuning of the others. So, what I did was I first did a rough tuning of all the three potentiometers, then I went back and refined the original tuning, and then again and again and again until I was satisfied of the shape of the signal on TP1. And yes, you do need an oscilloscope for this tuning. It doesn't have to be an expensive one, but it is better if it has a bandwidth of at least 20 MHz, so that it can capture enough harmonics of the signal to visualize it well. During this part of the tuning process, it is important to read the frequency of the Pitch Reference Oscillator with the best possible precision, which is difficult since it tends to change continuously because you are moving around the unshielded circuit and the frequency keeps changing. But the point is that we need to know this frequency value because we will have to tune the other oscillator at a frequency slightly lower when it oscillates at its maximum speed. It is important that the Pitch Reference Oscillator works at a higher frequency than the Pitch Variable Oscillator, but it needs to be just a little bit higher so that the difference between the two frequencies falls in the audible range. Once tuned the Pitch Reference Oscillator, I moved to the Pitch Variable Oscillator. First, I inserted U3, U4 and U5 in the corresponding sockets and connected the antenna. Then, I started tuning the three inputs R11 and R12 as well as the variable capacitor C16. Now, this is very tough to do, because while doing so you are close to the antenna, and so every movement of your body causes the frequency to change. So what I did was mainly to make sure that the oscillator could work well, adjusting R12 for the positive feedback and R11 for the amplification value. I even turned on and off the device several times to make sure that it kept working every time it was turned on again and that it was providing always the same frequency. Last, I tuned the capacitor C16 to reach the desired frequency value. Last part to tune was the negative feedback loop of the op-amp in the mixer stage. So I put the op-amp in the socket and then connected the oscilloscope to the output of the audio generator. Remember that the signal coming out of the op-amp U6 has to be high enough to correctly polarize diode D1. If the signal is too low, the diode will not work and there will be either no signal or a distorted signal at the output of the generator. So the tuning here consists on adjusting R20 until the signal at the output is strong and perfectly defined, as you can see here in the oscilloscope picture. During the tuning and first attempts to testing, I realized that there were some issues with the audio generator. Two things strike me. First, some excessive noise at low frequencies in the audio output, and second, the range of frequencies of the Theremin was very poor, just about 1 octave. I quickly realized that the noise was coming from the pitch control potentiometer and it was caused by the loose connectors on the PCB. To fix the problem, I decided to solder directly the cable to the potentiometer directly to the PCB without using the pin connector. I also noticed about the potentiometer that I wasn't using the whole range of it to tune the pitch of the Theremin. I needed something with a finer resolution. After giving some thought to it, I ended up using a 10K trim pot in series with 1K potentiometer. I could have tuned the trim pot to stay in the middle of the necessary adjustment range, and so the only needed element to fine-tune the pitch remained the 1K potentiometer that could be used for its whole range. Moreover, since I noticed some issue due to the intrinsic inductance of the multi-turn potentiometer initially used, I decided to use a regular potentiometer to also avoid that problem. The effect of these changes was terrific. The sound became clean, and it was much easier to adjust the pitch of the audio signal. About the second issue, the range of the frequency that I was able to play, I decided to go back to the drawing board and, in particular, to the mathematical model I made when I designed the Pitch Variable Oscillator. Let's take a look together. As you can see from the curve obtained with the inductor in series to the antenna, it is true that the change of the frequency is more linear than the other curve. However, if you notice, to have a considerable range of frequencies on the y-axis, we need to make big changes of the capacity of the resonator tank, described by the values on the x-axis. The problem is, the capacity of the antenna and the hand do not change that much, so the range of frequency is limited. So how do we solve the problem? Well, let's take a look again at the RF diagram, the one obtained without the inductor in series with the antenna. Look at the very left side of this diagram. The curve is very steep, which means the frequency changes quickly with a small change in the capacity. And did you notice that the curve is almost straight in this interval? So you see, in my first approach I thought that the capacity would change greatly when moving the hand in front of the antenna. But this is not true according with experimental data. That means that we can use that small range on the x-axis where the curve is very steep. Here is what I did. I removed the inductor L2 in series with the antenna and I short-circuited the pads of the PCB where the inductor was located. So this connects the antenna directly to the resonating tank. Also, to reduce the capacity, I removed entirely the capacitor C15, leaving the pads empty, the space on the PCB empty, so leaving only the variable capacitor C16 in place. This moves the range of the capacity all the way to the left in the mathematical model, and so close to the section of the curve that I would like to use. And there we have it. We can now move along the section of the curve that is almost straight and provides a large range of frequencies. However, this change causes a side effect. Reducing the capacity of the resonating tank increases the oscillation frequency of the pitch variable oscillator, which we can deduce also from the diagram. But the frequency of the pitch variable oscillator must be lower than the frequency on the pitch reference oscillator. So now, with the changes made to the pitch variable oscillator, the pitch reference oscillator does not have anymore a higher frequency. In order to keep the frequency of the pitch reference oscillator higher than the pitch variable oscillator, we now have to increase the oscillation frequency of the pitch reference oscillator. And this is an easy fix. It can be achieved just by decreasing the value of the capacitor C1, which I changed from 470 picofarad down to 250 picofarad. Now that both issues were solved, I expected the Theremin to work much better, no noise in the audio and a greater range of frequencies in the spectrum. And in fact, after I made these changes, I had to go, of course, again through the whole tuning procedure, but at the end I had the device working exactly as I needed. So it was time to make one final test, try to play something and see how the audio generator behaved. So, not much else to say at this point, just listen to the attempts I'm about to make to play something on an instrument that fundamentally I never used before. And just remember, at this time I cannot add the dynamic to the sound, since the volume control block is not done yet. So there is going to be some noise in between the pieces and within the pieces themselves. Anyway, enjoy! Okay, let's start with some sci-fi noise. Amazing Grace now. How about now with the original Star Trek TV show soundtrack? And finally, the Stargate movie soundtrack. Okay, I guess that's enough for now. Thank you. Okay, this was a video full of interesting information, and not to mention the small concert I just performed. We have seen how the three components of the audio generator, the Pitch Reference Oscillator, the Pitch Variable Oscillator, and the Heterodyne mixer were put together on the same PCB, then how the entire circuit was tuned, and the changes that were made to it to have a better performing instrument. The one thing left to complete the Theremin is now the volume control block, on which I have already started working. As soon as I have something worth of showing, I will post a video on it. The one thing I didn't think much yet is the box for this new Theremin. I am debating if to use a standard aluminum case that I can easily buy from one of the electronic components online retailers, or instead make an elegant wooden case by myself. Any suggestion? Please let me know in the comments. Thank you for watching the video, and give it a thumb up please, which will greatly help in improving the visibility of the video so others can enjoy it too. And also, if you have not subscribed to the channel yet, please do so, it's gonna give me a help in making more and better videos. Talking about help, a small monetary contribution would do it too, and there is a couple of options that you can choose from, Patreon and PayPal, that are both listed in the video description below. See you on the next video, and as usual, happy experiments!